Hi, my name is Professor Willams. I'm the head of School of Aerospace, Mechanical and Mechatronic Engineering here at the University of Sydney. I want to welcome you to the labs at the Australian Centre for Field Robotics. Today we're going to show you a bit of some of what we do and share that with you during your break. I thought I'd start by introducing you to some of our agricultural robotic platforms. They're used to help farmers manage their crops and improve yields, to build better models of what's happening in farms. So this is RPIA. It's used in row crops where we have plants that are typically planted in a row. It's got a whole suite of different sensors and instruments underneath the hood here, so it can take measurements, build maps of the environments. It can even do autonomous weeding using machine learning to recognize the crop and weeds. It's equipped with solar panels, so it can run for 24/7 as required. It's got very high precision navigation instruments, so it can figure out where it is in the farm and conduct very long-term operations. So another one of our agricultural robotic research platforms is Swagbot. This one's designed for operating in rougher terrain, so in paddocks and things like that. We've actually used it to herd cattle, so it acts a bit like a sheepdog, but a sheep robot. We can also go out, take measurements of soil properties, deploy different imaging technologies to allow the robot to understand its environment, to get around. It can tow trailers and things like that. So it's a really versatile robot that allows us to go over a lot of different terrain on the farms. One of the things that we're particularly proud of is our ability to translate our research into practice. So we've had a number of startups that have come out of the Australian Centre for Field Robotics, including a Garris, which is one of our agricultural robotics spin-offs. They've taken a lot of the technology that's been developed in our agricultural robotics programs and have turned it into a commercial offering for farmers. They're looking at supporting sustainable practice in both small and large farms, and are one of two agricultural robotics spin-offs from this centre. So this is another one of our robots that's used to support agricultural applications. It's a drone, well, amongst other applications actually. So it's a drone. Everybody may be familiar with the small drones you can buy down at the local shops. This is obviously a much larger drone, can carry much larger payloads, quite heavy cameras and other instruments. And we use these sorts of platforms to build maps of the environment. That may be on farms, it may be up on the barrier reef, looking at water quality. We do a lot of work also in the defense sector with these sorts of platforms. So this is one of our intelligent transportation systems test platforms. It's used to develop new autonomy methods for on-road applications. So we use this sort of platform to develop perception, control, and planning algorithms that allow these vehicles to operate on roads and around campuses. So my own research is focused on developing marine robotic platforms. So we do a lot of work with autonomous underwater vehicles. This is our AUV series. We've used this platform to document sensitive habitats all around Australia, looking at coral reefs, kelp habitats in the south, canyons, and have even taken it overseas to map ancient shipwrecks in Greece. So it's equipped with a whole suite of sensors, including sonar, high-resolution cameras, water column measurement systems, and we take all that information. It's all collected by the vehicle, and then we make that information available to scientists to help them better understand the marine environment. This one here is a smaller AUV, also an autonomous underwater vehicle, and it's used for collecting very similar information than our larger vehicle series. It has high-resolution cameras, acoustic positioning systems, and a suite of sensors that allow us to map the environment. We've actually taken this one overseas as well and have mapped ancient settlement sites in Greece. It's a 3,500-year-old city that was discovered on the Greek coast, and we use this platform to map that with a team of archaeologists. So this robot is an autonomous surface vessel. It's a robotic boat, and it's used for a variety of different applications. We use it for mapping the environment, for tracking our autonomous underwater vehicles, and we're currently developing some technologies that will allow it to deploy and recover autonomous floats to help us map the seafloor. Jackson and Will are two of my PhD students, and they're developing technologies for marine robotic systems. And one of the things Will is working on with a little startup in Sydenham called the Blueprint Labs is autonomous manipulation. So we've got a little grabber on this ROV, we're developing technologies to allow the robot to go and sort of pick up objects in the environment. So this robot's called Groundhog, and it's used as a platform for testing new perception algorithms and sensors. So at the moment we've got it equipped with a radar system, lasers, infrared cameras, and we use that to map the environment and to help the robot understand what's around it. We've done deployments of this platform at Jervis Bay as part of a program called Autonomous Warrior, where we were doing demonstrations of combined air, ground, and surface vessel operations. So that's all we have to show you today here in the Center's labs. We hope you've enjoyed the tour and really look forward to perhaps welcoming you to Sydney University.